Yeah, don't worry. At the end, we're going to drag out these. They look like fancy bar stools, but we're going to drag them out, and we'll have plenty of time for question and answers. It's interesting you talk about wind-up windows. I was with a group of probably 40 or 50 people, and somebody asked about basic hand signals. And I asked how many people in the room actually know how to do a right-hand turn hand signal. And only about 3 hands in the room went up. John Zangari does, but other than that, yeah. Next, I'd like to invite Jeff Ruel up from Autoliv. Jeff, we'll see if we have your presentation up and ready here, and let's hear what you guys are up to.
Thank you, sir. So I'll give you a very, very brief introduction to Autoliv, because we are kind of we're a Swedish-based company designing safety systems for automobiles, and we have a very singular focus on safety, which makes us kind of unique in the market, and we're very quiet going about doing what we do. So you probably don't know the brand or the company. So I'll give you a very brief introduction and then talk really more about what are our motivations. Why do we do what we do? What drives our way of thinking? Because I think that's important to this whole discussion. Autoliv is a big company. It's $9 billion, roughly 60,000 people working in 89 countries around the world making safety systems. Important to understand that we work with just about every single vehicle manufacturer in the world. Okay, so we have a pretty good understanding of what's going on in the marketplace. And in terms of the number of products that we make, as I said before, we're focused very much on saving lives and reducing injuries in the car. And we do that through a number of ways, through passive, which is our traditional business, talking about airbags and seat belts and these kind of things. But more and more of our future is becoming related to active safety and sensors such as radar and machine vision and infrared and the ability to combine and fuse all of these technologies to do more intelligent things in the vehicle. Okay? Again, I want to drill down a little bit into our DNA, right? This is probably the second most important slide in this deck. And we're very proud of the fact that every year our products are saving over 30,000 lives and preventing 10 times as many injuries, okay? And we have proof of these, seat belts in particular, but also airbags. And I'll explain what happens in the future. But this is our DNA. This is who Autoliv is, and it's very much why our OEM partners, such as GM and others, rely on Autoliv so heavily in developing and engineering safety systems. And again, why? If we look at the World Health Organization data, oops, I've done something wrong. Here we go. There's 1.3 million traffic deaths that happen in the world every year. It's the number 9 leading death cause in the world. But if we forward project that into 2030, it becomes the number 5 cause of deaths in the world. Okay, so we don't have to think too hard about this. It's fairly obvious that this is a problem, and it's a growing problem, and it's one that we're absolutely compelled to resolve and address. Okay, and you can see here in the list HIV, AIDS, and cancer, and diabetes, and other things. Automotive deaths are actually higher. They're driving more deaths than these things we think of as the chronic killers in the world, right? And another thing to understand, 50% of all the deaths that happen on roads happen to vulnerable road users. These are people outside of the vehicle, right? It's not the occupants of the vehicle. So we make airbags and seatbelts and these things inside the car to save people. But in fact, half of the available lives we can save are outside the vehicle, pedestrians, cyclists, mopeds, motorcycles, these kind of things. This is fairly important. Yeah, it's something that we have to look at from an accidentology standpoint and address. So how do we do that? We've talked about statistics. I've given you sort of a look into the Autoliv DNA. This is mine. Right? The challenge is to make safety personal, right? It's not just about statistics. That's my girls. That's personal. And we talk about saving lives. What is the road to saving lives? It's protection, it's prevention, and then it's automation, and it's levels of automation, it's layers of automation. It doesn't happen all at once, as Mr. Kapp has told us. And really important to understand here that the key to all of this is, here I go again, is addressing the element of human error. Human error drives over 90% is the cause of over 90% of all accidents on the road. It's human error. So whether it's distraction, whether it's the human-machine interface being overly complex, whether it's and all these other things that will happen, the automobile will continue to evolve. The question is, how do we deal with this issue of human error? So what I'm going to show you here is a series of videos, just a glimpse into technologies that we're working on to show you how we address with it. We have a driver monitoring system where we're looking at eyelid closure and we're looking at gaze direction to try to understand, are the driver's eyes on the road? Right? Because we need to understand, is the driver focused in doing this primary task or not? So by looking at the eyelids and understanding gaze direction, we talked about the amount of time the driver, that we need to be looking, we think it's something on the order of 2 seconds, 2.2 seconds, something like this, where we need to alert the driver he's not paying appropriate attention in the car. Right? So driver monitoring is one way, using a camera and infrared illumination and trying to understand gaze direction, eyelid closure, and these kind of things, so that we can try to deal with some of these distraction issues. Another such idea is, can we aid when the vision is compromised, right? So we make far infrared technology for night vision, smoke, and fog situations. And what you see here is a simulated a heavy smoke and fog situation. And you can see the difference in the left and right side of what a night vision system can see, an far infrared-based night vision system can see, versus what the human eye can see, right? And so there are situations where the human is not as capable as the technology would enable, okay? So there's another example. The question, can we brake when the driver does not? So here what you're going to see is the description of a problem, forward collision avoidance, autonomous emergency braking, crash imminent braking, lots of different. But here's lot of ways to describe the problem. Here's a simulated city that we built in one of our test facilities. And we can run pedestrians and cars on wires and in control and do it in very controlled ways. But this is what happens, right? A pedestrian walks out in front of a car, the driver never sees it, you have no reaction time, and you've hit the pedestrian, right? And it's pretty alarming. But the solution is to start having sensing systems that can find the pedestrian, identify the car, and enable the vehicle to brake autonomously when the driver hasn't done so sufficiently, okay? And you can also see here, so it's pedestrian scenarios, but we're also doing the same thing with vehicles, right? We make these balloon cars and these simulated environments where we can do testing of autonomous emergency braking systems based on radar and machine vision fusion systems. Okay, so this is just, again, some examples of the type of environments and the test areas that we're trying to develop and solve these problems. And finally, can we identify a safe place to put the car? So we talked about, is the driver looking at it? How can I help the driver see better? We talked about, can I brake when the driver's not doing it sufficiently quickly enough or missed it altogether? The next question is, can we identify a safe place to put the car? That's a steering maneuver into a safe place, right? So that's the next frontier for us. And some of the things that we're working on are things like free space detection and road surface modeling. I don't know if you can click on this, if it will allow. This one's not starting for some reason. Okay, it doesn't matter. We can save this for discussion. You can see in the static image here, this is an image, a surface map effectively from a stereo vision camera system, where we can start to understand where are the road edges. And as you understand, as you see this driving scenario, as cars pass, as pedestrians move past, we can understand, basically have a three-dimensional view, depth and height and so forth, and understand what's happening on the road, and start to understand where is a safe place to put the car. So not only am I braking then to avoid an accident, but I'm trying to understand where can I put the car safely. So it's sort of a next frontier, another part of automated driving that the likes of Autoliv and NVIDIA and General Motors are, and many, many others are working very, very hard on at the moment. So just some closing remarks from my side. We have a challenge in front of us, right? But it's fact. There's a lot of challenges, as John has pointed. But few things in life worth doing are free of challenges, right? So that's not going to stop us. Driver distraction, for sure, it's an emerging and serious challenge. But it turns out this isn't really something new. Human error is already the root cause of most accidents, and it has been for a long, long time, right? Since the beginning. The amount of distractions, the amount of the things that are causing or creating human errors is changing, is evolving, and it will continue to. What we have to do is address the root cause, which is human error, and we have to be looking at that and working on that continuously. The new technologies that we're developing are not perfect, but they show great promise. Really great promise to reduce and eventually eliminate human error from the equation, right? And I've given you a glimpse, a little core sample of our DNA, I'll try to tell you why we do this, right? There's a challenge that we have to solve. And I guess there's a challenge for you guys as well, right? The question I have is, how can you make a difference within your circle of influence, right? You have a role in this as well. Writing about these technologies, to be able to communicate why do we develop them with some clarity, so that we can put it in a certain amount of context when something doesn't work exactly the way you might have envisioned it, or the interaction isn't as slick or as perfect as you might have envisioned. I challenge you to think about, why do we do this? Why are we developing these things? And what is our end goal? Why do we want to get there? And try to put some perspective around this to make sure that we're helping to get to the desired state, right? Which is reducing traffic accidents, injuries, and so forth on the road. So I make it personal. I guess the challenge is for you to do the same. So with that.
Thank you very much. Yeah, it really is the idea of making it personal and becoming involved with your car. And like you said, what's the point of life if there's no challenges in it? So certainly, words well spoken.